So suspension system of a car, question number 19 is this. The suspension system of a car is a set of springs that allows the body of the car to move vertically up and down relative to the wheels. A car is driven along a straight road that has a series of speed bumps. Speed bumps are raised part in a road as shown. It is actually we are using for reducing the speed. It's actually a speed breaker. So at a particular speed of the car, resonance occurs. The amplitude of the vibration of the car body on the suspension systems becomes much larger because at resonance, maximum amplitude will happen. Explain why the amplitude of vibration increases at a particular speed. Explain why the amplitude of vibration increases at a particular speed. So how will you answer this question? It's a 2-mark question. So here you can say, what happens in resonance? The driving frequency of the car is same as the natural frequency of the car, because usually every object has its own frequency for vibration, and car is actually driving with a certain velocity, right? So what happens? The velocity that is produced due to the driving force, that causes a frequency. That frequency and the natural frequency of the car becomes equal. At that moment, what happens? What happens is, at that moment, there is a maximum transfer of energy. So when maximum energy is there, obviously, maximum amplitude will be there. That is the idea behind it. So can we write the valid points here? We can say, at resonance, the driving frequency is the same as the natural frequency of the car. That is the first valid point. So what happens as a result? There is a maximum transfer of energy to the car body. When maximum energy is transferred, maximum amplitude vibration happens. So this is the answer for this A part of this question. Now, when a person of mass 65 kg steps into the car, the vertical height of the car above the road decreases by 2.5 centimeter. Resonance occurs when the speed bumps are spaced 25 meter apart. Calculate the speed the car is driven along the road. You should consider the car as a mass spring system. Mass of the empty car is 1300 kilogram. So obviously, it's a 5-mark question. So our aim is to find the speed of the car. So how will you answer this question? So resonance is actually happening at every 25 meter apart. So you can do one thing. From this, you can calculate the time period at which this is happening. How? We know basic equation for force is mass times acceleration due to gravity. And due to this, what happens? A spring is compressed. So that means a spring force is actually developing. A restoring spring force is there. So what is that equation? Minus k into x. Am I right? Therefore, if you are equating this, and we can develop what? We can equate these two equations, and we can develop the equation for time period. How we can equate this and find the time period? Because this is a simple harmonic motion. We know that the acceleration of simple harmonic motion is expressed as the acceleration of the simple harmonic motion is expressed as acceleration is equal to minus omega square x. Acceleration is equal to minus omega square x. So force is mass times acceleration, and that is equal to minus k into x, minus k into x. So if we are comparing this, the acceleration is minus k by mx. So from this, we got an idea that k by m is equal to omega square. So omega is equal to square root of k by m. 2 pi by time period is root of k by m. Therefore, time expression for time period, we can say it is 2 pi into root of m by k. So from this, you can calculate what? You can calculate the value of the time period. Anyway, the k value, the spring constant value is not given. So we can equate this and find the spring constant value. M into G is equal to K into X. We are actually equating the magnitudes. So equate this. And what is the mass? Mass, because actually the empty car is actually acting as a spring. Now, a mass of 65 kilogram is placed. As a result, it's compressed. So here we will be using the 65 kilogram. So 65 into 9.81, because acceleration due to gravity is 9.81 is equal to k times what is x? X is, it decreases by 2.5 centimeter. So 2.5 into 10 to the power of minus 2. So from this you can calculate k. 65 times 9.81 divided by 2.5 into 10 to the power of minus 2, and that we will get it as 2.55 times 10 to the power of 4 Newton per meter. Using this value, you can calculate the time period. 2 pi into root of, here what we should do? Here we should use the mass as the entire mass of the system, because due to this mass, because don't confuse with these two masses. Why in the first case we are only taking 65? Because that mass is responsible for the compression. But now for the frequency, the entire mass system is it's vibrating. So we have to consider the total mass. So 2 pi into the 1300 plus 65 means 1365 divided by the K value is 2.55 into 10 to the power of 4. So if you're plugging this value, you will get 1.45 seconds. Now, why we calculated this time period? Because what is our aim? Calculate the speed of the car is driven along the road. You should consider the car as a mass spring system. The resonance occurs when the speed bumps are spaced 25 centimeters apart. So here, this is our speed bumps. So the distance between them is 25. The first resonance is happening. The time after which the next resonance is happening is 1.45 seconds. So the speed with which it is happening, the speed is equal to distance over this time period. So distance is 25 divided by this time is 1.45. So that is 17.2 meter per second. So the speed is 17.2 meter per second. Because we use the equation, speed is equal to distance by time. From this, we calculated this value 17.2 meter per second. Now, next, C part of the question. Explain how damping reduces the large amplitude of vibration of the car on its suspension. How this damping will help us to decrease the large amplitude of vibration. So we know that amplitude increases due to the high energy transfer. So if you are removing this high energy transfer, we can reduce the amplitude. So how we are removing? The energy is dissipated to the surroundings by the damper, with the help of a damper. So as a result, the vibration energy decreases and hence the amplitude decreases. Clear? So we will write kinetic energy is transferred to the suspension. Kinetic energy is transferred to the right word is dampers, because damping is happening. So transferred to the dampers. Now we can add one more point. The energy is dissipated to the surroundings due to dampers. As a result, vibration energy decreases and hence amplitude decreases. Amplitude of what? Amplitude of vibration decreases. Clear? That is the answer for this C part of question number